Hey there, and welcome back to Stationeers. Welcome back to another episode of Learn to Code. Today, we are looking at lights again. Some time ago, we did a simple light setup where we could flip a switch, turn on a light, flip a switch off, turn the light off again. And we did the same thing with IC10. Then the whole change of the game happened, and our testing will actually disappeared. So I've now created it again. And not the same place as last time, because we are on Mars, as you can see. I chose Mars because we would like to have an atmosphere. So in terms of testing, it would be nicer. Anyway, I made these hubs, as you can call them, that will be storing each segment. So here we have, and I named them so in terms if I want to share. Anyway, I'm messing around. As I said last time, we could flip a switch, turn the light on, turn the light off. That's it. What if we took a switch? Let me see, there are two switches. If we took a switch, popped him there, bought another switch. So we have two switches or multiple switches. And with them, we would like to turn off and turn on lights. Basically, if you had a door here, and you had a door over here, you would like to turn on the switch, click the switch, and it would turn on the light. You would probably use a sensor for this, but if you are using a switch for it, this is how you would set it up. So to set this up using logic, you need to use 4 I/O, 2 memory, and 1 processor. Sounds quite daunting, and it might be. It is actually not wasting of power, but there are some unique features that this lacks that an IC10 chip would provide you. But we will get to that later. Let's first start putting up our things. So we want a memory up here, and another memory. Let's see, we take this one. So we call the first one toggle value, or toggle, or yeah, whatever. Toggle value, and we call the next one logic. And just so we are clear, so you know, when you are highlighting it with the label on, you see the square. That means you're naming the actual unit. If you are highlighting the 2 circular screws, so the big one and the small one, you can set same on the left side, you can set the value. And that is pretty much what you can use for label. If you want to use a screwdriver, the big one takes big values, so hundreds. So see there, we go from 0 to minus 100 in value. And same over here, it goes to plus. If you take the small key screw, it takes in single digits. Now that we named the toggle and the logic, we actually want to set the logic to 1 straight away. That is just a compare value that we're going to use later on. We are also going to need a I/O to read, so we're going to need a batch reader. Let's see here, the batch reader. And this, of course, will be reading these 2. So we can take some cables. That's on here. Cable. Yes, I'm still in test phase, so that's why it looks like this. This setup that I'm doing, you would never be able to do on a normal base. At least it will be strange if you did. You would probably have these on a sitting throughout your room, and they would simply just be on the same network as everything else. But here I don't need that. Right, next thing, we need a compare unit. So a compare unit up here. And we have 3 writers. So we have a logic writer. And another logic writer. And a batch writer. Right, so the first one we name what you call it, light light activation, light writer. Yeah. Yes. So these 4 are what is doing the toggle that our batch writer for the light will react to. We will need the toggle value to be triggering on, off, based on when we click on the buttons. So the batch reader we can call switch reader. Switch reader. This logic writer we'll call logic writer toggle. Okay, and this one we will call value toggle writer value, and just logic compare. That doesn't matter. It's the compare of the toggle. We could call it logic toggle compare. Toggle compare. We could call it that. Right. Let me just cable all this up, and then we'll get on to setting everything up. Awesome. So there we have all our things wired up. As you can see, I don't need a wire between this. These 2 are standalone. You would have a cable there, I guess, but I didn't need to. So they are looking at the buttons, and we are looking at the sum and of the setting. We could also look at the activate, but setting is the more straightforward one to use. So if you see there, it says 0, click 1 0. Got it. It goes in and out. It's like a spring return, you can call it. On the logic writer, we want to activate this one. So on the in, we want the logic reader. So the switch reader, we want the logic writer value, and we want on. Basically, you click here, let me go here so you can see it, click, boop. You see that blink? It's of course an error right now, doesn't matter. But it goes on for a split second to do something. It will send a do that, so you trigger it. And that is the toggling bit. Right, so he will be on the in of this logic writer. We want to look at the compare, because we want to compare these 2. That is what the compare is doing. So on the compare, we can set that up first to avoid confusion. So the toggle value, which is this one, will be on number 1. So let's see, toggle value there. Oh, I've missed a cable up there, I can see. Let's just get that in. So we are. That's the blink. That's good. We like blinking. And on the opposite side, we want a screwdriver in my hand and the logic. I could, of course, call it logic memory, but so we want to do not equals on this one. Now we are. Next, we want this one to look at the toggle compare. So logic toggle compare. And he will then set the value of the toggle value. I hope this makes sense. Let me see here. Toggle value. Yeah. And setting. So what's happening here? This is quite funny. So the compare unit compares the toggle, compares the logic, which has a fixed state of 1. It will never change. If it changes, it'll break. But we have it as fixed as 1. We check that with the toggle value as a not equal. So if these 2 are not equal, he is correct. If we then turn this one on, he will look at the compare. And if the compare is 1, like here, he will then send that one to the toggle value. And then this will be false, meaning 0. If he then runs the logic writer again, he will then send a new value to the toggle value, which will be 0. and hence a toggle or flip-flop function. And as we are turning him on with this logic right down here, it's like a pulse. He will not stay on for a very long time. He will stay on for one, not second, but one shot, and do his thing, and off we go. Hope that makes sense. The batch writer is the simplest thing of all of this. He looks at the toggle value. So go to toggle value, and we go put the output on whatever you want. In our case, wall lights, that's it up here. We want to do on and turn on. Okay, let's try this out. So everything is ready. He's in 0, everything is ready. That's off, good. Click, and he's on. Click on the next one, and he's off. And that is actually a flip-flop function. Flip-flop function. Now there's a place here, like I said, where it's not really good. We don't know which button we're clicking on. So we could have multiple of these activation buttons in the room where this function is located, but they could be called something else than, or technically be used for something else than turning on and off the light. But with this setup, we don't have that. We don't have, so we can read the batch and check it. We could do some really funky stuff to check these, but it will take a lot. Like right now we're using 40 watts. 50, you want to take this one in account, but that one is only on for a split second, so it doesn't really matter. So you are still cheaper than IC house. But if it's a room you're building, you would do more than just light. But let's see how this setup, which for me looks quite complicated and not very flexible, would look on an IC housing. So here we are with our lovely IC housing. We have everything pretty much set up the same way as before. I say that, but we haven't, because we don't have half the things. We have a switch or a button. We have another button. We have the IC housing. We have the 3 lights before. So the 3 lights are the same thing. And for this, we will need a laptop or a computer. I use personally a laptop because I find it more nicer to use. We plug in the laptop, the IC chip into the laptop so we can moderate it. Always when you put it in and you don't know if something on it, I can see this one is 0 bytes, so it should be empty. But just click that import. Just click it, so you know you have whatever is on this device. Now, what is we want to do? Well, we want to control some lights, which are wall lights, with some buttons. We'll be using something in the IC chip that we can use in Logic, which is the hash setup. So first we're gonna get our buttons. So button, click this. So this is our Logic switch button that we're using for this function. Of course, if you are using a different type of button for whatever you're coding, you will need to find that specific button. For a flip-flop, this one is the ideal because it will come back automatically. So you click on the prefab hash and you say copy to clipboard, meaning that that line of numbers is in your clipboard ready to be used somewhere, and we'll use in here. So on line 0, you'll do a define, and we'll call the define, say button, and you store that number there, meaning that when you type something and use button, you have these numbers. So you don't have to remember them, basically. We'll do the same thing with the light. So wall light. And there's a lot of different light comes up. And here you see you have kit lights and you have wall light. The kit light is the light that you build. And you can go down and see all different types of light from the kit they built. When I mean kit, I mean take it down. Just a second. Really? That's a kit. And by kit, it can go to all these kind of things. So all these that I'm flipping between now is what you can see here. So let's just pop it up here again as a wall. So we know we have a wall light, which is the ugly one. I prefer the light round, which I have up there. Those two. Anyway, I'm mumbling again. So we again take the prefab hash of the wall light. Click on that and go into your laptop. A new define. So this one we call light and the number. So see, that's very different compared to the other one, but that's just how it is. We don't have to think about it anymore. Next thing, we need a memory value to know where we are. So we're going to do a alias toggle value, and we're going to do this one to R0, and straight away, just to be sure that it's correct, we do a move R0, a toggle value, and 0. This should not be necessary. It's simply just to ensure that this value is 0. That's all it's doing. It's not really, shouldn't be important, because once you plug it into the IC housing, it will reset all the known values. Okay, so we need to do some coding. Well, what do we need? We need to load in the values of the buttons. We need to check if we are toggled on or off, and we need to write to the lights. So all that is a constant looping sequence that we need to do. So we first will start with start, or let's call it loop today. Why not? And we're going to do a J loop. And as before, the J loop, when you hold on it, you can see the J and it goes to int. I've named a line, which is an int, which is line 5 in this case. I've named this line loop, meaning that when I write loop here, it knows go back to number 5. That is what this is doing. It's just a circle. So, and you always need this, unless it's something odd. First thing first, let's do a load batch. Now here, we can do something quite nice. So we can do a load batch name. And we take the button, so we can do that to, we put the load batch value into a register, and we just put into R1, because I don't know why. I don't know why. Let's put in button, and let's put in hash, semicolons, and those ones. I may have named that incorrectly, but put that in. Put it in setting. And then we need a batch mode. Don't forget about the red one right now. We need a batch mode, and a batch mode is what type you need. Same as on the logic, it asks you if you want average, or sum, or minimum, or maximum. We want sum. We could also do maximum, but we do sum. Sum is just like Excel. It sums up how many is there. So we do sum, and you can type it as sum, or you can type in 1, which I do. Yeah. Now, why is the hash empty? Well, if you click OK or confirm, these are called buttons. That's the name. If we add one more, let's see here. We add one more here. Like so. You don't need to do this. I just want to show you why I want it to be named. And we call this one button. Wow, light. We copy that name to here. So those two are called button light, but this one is just called button. We take the same in here, put it on there. So far, so good. We now know that we have to look at the buttons and with the name button light. So if there's more than one, perfect. If there's only one, okay, also good. Great. Now that we have got a value into our button, from a button into this register, we need to do something with this value. And we can't do it. We could do it in here, but I prefer to just quickly go out and go through it and then come back in. So if you do a batch greater than 0 and then put AL on that, that means that we come back to this line once we're done with our code. If a register is bigger than 1, then means that it will jump, then this line will execute. So if you do R1 and we jump to, let's say, toggle, it'll be red for now, but that's fine. Basically what this means is that if we are pressed one of the buttons called button light, then this will be true because the register will be 1, and then it will jump to toggle, which is a new function area, a new line, where it will then do whatever is there and then jump back to this code eventually, because this line is stored in raw. Okay, I hope that makes sense. Down here, we do the toggle function. This is basically a sub-function. So toggle and those two. I cannot remember any of those fancy words, so bear with me. Here we do a yield. A yield is simply a small wait, a small delay, like, hey, break, have a look, have a pause. What you can do here? Well, this is where we are going to set the toggle value. So we're going to do a move and move that here, put that to 1, and then JR. So basically we jump back to that line. Perfect. Or is it? Well, we click the button, we get it to go to toggle if the button has been clicked and we have the value of 1, bigger than 0 technically. It goes out to toggle, where we have a little bit of wait, a pause for 1 tick. Then we put a value of 1 into the toggle value, but we don't put a 0 value into it anywhere. Where would you do that? Well, I would do that here. So if we put in batch greater than 0, simply a jumping line, so we actually jump again straight away. If toggle value is greater than 0, we need to toggle off, not toggle. So toggle off, like so, and go down here. And here we're going to do a move again. Move 0, so now we need to turn off, so they are again. So both of these are doing the same thing. But it cannot activate both at the same time. So if toggle value is 0, it will jump. Nope. If the toggle value is 1, it will jump down to toggle off, meaning that, hey, the lights are on, turn them off. If it's not 0, if it is 0, it will go down to toggle value to 1 and then jump back to R. So both of these are doing the same thing. Now up here, we can do a set batch, and we're going to do a light. We're going to do an on. And we're going to do a toggle value. That's not how I spelled that. That's great. That toggle value. Then that's it. This is the same function as you made over there. Let's export this. Let's put that away. So, pop it up there, turn it on. They're not on. Click that. They're on. They go off. Click that. Nothing. And this is what I'm saying. because we have defined these two buttons as button lights, they will activate the button lights, but no other buttons without the button light name and the same button type will be able to activate said lights. Hence, we have some security without using any pins, because pins are very annoying. But this is a flip-flop version of that. Now you may ask yourself, that is not a very nice code. No, it's not. But it's working. You can do it several ways. You can also in here jumping over the lines when you want to toggle. This is just very easy for you to read. I hope it is. So basically, yeah. Again from the top, we get the value in from the switches, from the buttons. If the value is in and this register is 1, we jump out of this loop to toggle. In the toggle, we first have a wait. Then we check if our current toggle value, which is up here and the saved value, is greater than 0. If it is greater than 0, it's probably 1. And then that would mean that let me just spell that correctly. Toggle. There we are. Yes. I've spelled toggle so many ways. Okay. Toggle. I think it's all correct now. It doesn't matter. Yeah. So once we get to toggle, we check if toggle value is greater than 0, and if it is, it's probably 1. If it's greater, then we want to toggle. Then we're trying to toggle the light off. You would think, at least. Now, then we jump from the toggle down to toggle off and move 0 into toggle value and jump back to the loop sequence area. If it's not greater than 0, that means it is 0. Then we move 1 into the toggle value and then jump back. And then whatever status the toggle value has will be sent to the lights. And it's that simple. And of course, if you take it out, so you take that out now, you see now the light's on, you can't do anything. Plug that in, he goes to 0, and that is because of that. Mainly. We could, where is it? That one? Now he's commented out, and let's put that in there. You see, he actually stays there. So I personally prefer to know that all. Wow, nice. I personally like to know that all my registers are 0 before I use them, unless it's something, not important. But hey, that's it. That's all for today. Before I leave you, this is my testing base from now on, and the function I made on the moon, is still here, and I'm still working on it, and soon I will show you what it is. It's quite cool. It's something I need for my Let's Play world. But yeah, and here is, so I'm saving each as a house, and once that is complete, then I'll be uploading it, and then I'll see if I can upload them regularly so you can actually access these setups, because they are nice testing beds, and I've tried to name them according to the YouTube video, but yeah, that's all for today. Take care, everybody. Bye for now.